We are starting a brand new unit today. This is 2-1, Relations and Functions, and I think that you will remember this from your past. This is a pretty easy lesson, so hopefully you like this one. So first of all, a little vocabulary. A relation is any set of ordered pairs. So this is a set of ordered pairs. This is an ordered pair, this is an ordered pair, this is an ordered pair. So any set of ordered pairs is called a relation. And then in a little while, we're going to learn whether the relation is also a function or if it's not. Okay, domain and range. I know you've heard these words before. Today, domain and range will be really easy. Domain are going to be the first set of numbers in the ordered pairs, also known as the x-coordinates. And the range are going to be the second numbers in the ordered pairs, also known as the y-coordinates. So domain are x's and range are y's. And I had this little memory device that I used to say all the time, and it was Dr. XY, where's his ID? Which means domain are x's, which are independent, and range are y's, which are dependent. So Dr. XY, where's his ID? Just a little memory device that you can use to remember that domain are x's and range are y's. Okay, so in the next couple problems, we're going to list the domain and the range. And when you do that, you list the values in order, and you do not repeat numbers. Okay, so remember, domain are your x's, and I'm going to look in the x column, and I'm going to write them from smallest to largest. And then I'm just going to show you, this is a little set symbol here, and here. I am not good at drawing these, but I do my best. So when we list the domain, we put it in a set like this. So we have our left and our right set symbol. And this is what they look like down here. And like I said, I try to draw them as good as I can, but they're not the greatest. All right, so as I look at the x's, I look for the smallest x in the list, and it is -2. The next smallest x is -1, and I've got 2 of those, but I will only write it once. And then the next x in the list is a 4, and there's 2 of those, but I will only write it once. So I list the numbers in order, so that means smallest number to largest number, and I don't repeat values. So even though the -1 happened twice, I only wrote it once, and even though the 4 happened twice, I only write it once. So smallest to largest, don't repeat numbers. Okay, range. These are your y's, and they are a set of numbers also, so I'm going to draw my little set symbols. When I come over here and I look at my smallest y, it's a -2. My next smallest y is a +1, but only write it once. And my next smallest y is a 3, and I only write it once. So domain are your x's, and range are your y's. Smallest to largest, don't repeat numbers. Okay, so looking at number 2, I'm going to do the exact same thing. Domain are my x's, and so my smallest x is -5. My next smallest number is -3. My next smallest number is 0, and then 2, and then 4. And that's my domain. Range are my y's. Once again, I go smallest to largest. So my smallest y is this -2. My next smallest y is the 1. And my next smallest y is the 3. And once again, the 1 happened more than once and the 3 happened more than once, but I don't write it more than once. So domain are x's, range are y's, write it from smallest to largest, and don't repeat. Okay, so number 3 is another way of writing a relation. This was using a table, and then this is just listing out a set of ordered pairs. So the relation is still doing the same thing. The domain are the x's, and remember the x's are the first number in the ordered pair. The y's are the second number in the ordered pair. So just like in the alphabet, X comes before Y. Okay, so looking at all the first numbers, the smallest number that we see is -2. And the next smallest number is 0. And the next smallest number is 8. And the biggest X is 15. And that's my domain. Okay, my range, these are my Y's. So I'm looking at the second numbers. So first I'm going to look for the smallest one there is, and it's a 2. The next smallest Y that I have going on is a 3. My next smallest Y, a 9. And the biggest of them all, 18. So range are your Y's. Smallest to largest, don't repeat. Domain are your X's. Smallest to largest, don't repeat. Okay, do you remember that from your past? That's not so bad. That's pretty easy. Okay, this next little box tells us what a function is. And I have written it out in several different ways. And depending how I'm presented the information depends on which way I think about it. So the first definition says, a function is a relation, and remember, a relation is just any set of ordered pairs. So this is a relation, this is a relation. Any set of ordered pairs is a relation. So a function is a relation that assigns exactly one value in the range to each value in the domain. And that may not make sense to you, so I've got other ways of thinking about it. Basically, each X value can only have one Y value. So each X can only have one Y. In other words, the X values can't be repeated. However, it is okay for the Y values to be repeated. Okay, so I'm going to talk about these different definitions as I go through the different problems. So let's start with the easiest way of thinking about it. X's cannot be repeated. So let's look at our X column, and are any of these X's repeated? Yep, the -1 is repeated and the 4 is repeated. So because X's are repeated, then this is not a function. Let's look at number 2. So let's look at the X's, and are any of these X's repeated? Nope, none of the X's are repeated. So this is, yes, it's a function. And it doesn't matter about the Y's, it only matters about the X's. So X's cannot be repeated. Okay, let's look at number 3. Let's look at our X's. Are any of these X's repeated? Nope, none of the X's are repeated. So that means, yes, this is a function. Okay, and we're going to talk more about functions as we go through the rest of this. Okay, the next thing up is called the vertical line test. This is another way to figure out whether you have a function or not. So the way it works, you draw a vertical line anywhere through the graph, and if the vertical line goes through the graph more than once, it's not a function. So if any vertical line you can draw goes through the graph more than once, it's not a function. All right. So like if I drew a vertical line right here, I wouldn't hit the graph at all because the graph is made up of this curve and this curve. But if I drew a vertical line right here, I touched this curve once, twice. So if any vertical line I draw crosses the graph more than once, then that is not a function. If I try to explain it how I did up above with the ordered pairs, I'll show you that. So I'm just making up numbers. I'm just putting little tick marks on here. Okay. So if I was to write this as an ordered pair, I go right 1, 2, so my X is a 2, and I go up 1, 2, so my Y is a 2. If I try to write this one as an ordered pair, from 0, 0, I go right 1, 2, so my X is a 2, and I go up 1, 2, 3, 4, 5, so my Y would be a 5. So look at these X's here. See how this has an X of a 2 and this has an X of a 2? Well, we were told if X's repeat, it's not a function. So this is tying in two different ways to know whether something's a function or not. So if x's repeat, it's not a function. And if a vertical line crosses through the graph, it's not a function. Which a vertical line would cross through the graph more than once if those x's repeated. Okay, looking at number 2. If I was to draw a vertical line right here, I wouldn't even touch the graph. And I wouldn't touch it, and I wouldn't touch it. But if I drew a vertical line here, I touch it here and 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 here. I'm touching it everywhere along this line. So if a vertical line ever touches the graph more than once, then no, it is not a function. Okay, looking at number 3. When I draw this vertical line, I only touch the graph once. When I draw this vertical line, I only touch the graph once. When I draw this vertical line, I only touch it once. Only touch it once. Only touch it once. So this one is good to go. Yes, it is a function. Okay, looking at this picture, this vertical line touches it one time. This vertical line touches it once. This vertical line touches it once, touches it once, touches it once, touches it once, touches it once. So as long as a vertical line only touches the graph once, then yes, it is a function. Okay, this next one, the points did not print out well with my printer. I am out of colored ink, and that's part of the problem. Okay, so this is where they are. All right, so even with points like this, the same rule applies for the vertical line test. This vertical line only touched 1 point, so I'm good to go there. This vertical line only touched 1 point, so I'm good to go there. But what about this vertical line? It touched 2 points, so no, this is not a function. So if any vertical line can be drawn where you touch the graph more than once, then no, it's not a function. And what do you think about 6? It's a function. This vertical line only touched this is called a parabola, just so you know, only touched the parabola once. This vertical line only touched it once. This vertical line only touched it once, touched it once, touched it once, touched it once. So this one, yes, is a function. Okay. Next little page, we are going to make what is called a mapping. All right, and this is very easy to do. So instead of reading what's in that box, because you can read what's in that box, I'm just going to go through a problem. So the first bubble is for the domain, and the second bubble is for the range. So domain are what again? Domain are your x's. So I'm looking at all the first numbers, and I want to write them from smallest to largest, just like I did earlier. So the smallest x in this list is a -4. The next smallest x in this list is a 3, and it happens more than once, but we don't write it more than once. The next smallest x is the 8, and the next smallest x is the 9. Okay? Range, these are your y's. They're the second numbers in the ordered pair. So the smallest y that I have is at -2. The next smallest y is the 0. The next smallest y is the 1, then the 2, and then the 3. Okay, so it's basically doing what we did earlier. So domain are x's, smallest to largest, don't repeat numbers. Range are y's, smallest to largest, don't repeat numbers. And then we draw arrows showing what goes to what. Okay, so you see this ordered pair, 3, -2? That means the 3 goes to the -2. So I draw an arrow from the 3 to the -2. The second ordered pair is 8, 1. That means the 8 goes to the 1. So I draw an arrow from the 8 to the 1. This ordered pair 9, 2. That means the 9 goes to the 2. So I'm going to draw an arrow from the 9 to the 2. Okay, 3, 3 means the 3 goes to the 3. So the 3 goes to the 3. And the last one, -4, 0, means the -4 goes to the 0. And that is a mapping. Okay, now we want to figure out if this is a function or not. So we were trying to determine whether it is a function. Okay, so one thing that I like to think of for the mappings is this one, this definition. Each x value can only have one y value. So let's look. This x went to one y. This x went to one y. This x went to one y, but this x went to more than one y, so no, this is not a function. And of course, I can also see in the ordered pair that the x value of 3 repeated, so that's another way to know that it's not a function. If x's repeat, it's not a function. If you're looking at a mapping and you see an x value go to more than one y, then it's not a function. What that's like is if you went to McDonald's and you and your best friend both ordered a number 3, okay? So your number 3 looked just like your friend's number 3, but they charged you $3 for your number 3, and they gave your friend $2 out of the register. Well, that's not fair. You and your friend order the exact same meal, and you get charged $3 where your friend gets $2 back from McDonald's just for buying the number 3. So that can't function, or McDonald's is going to go out of business. If McDonald's did business like that, they'd be out of a franchise. Okay, so that's another way to think about whether something's a function or not. All right, let's look at this next one. So domain, remember those are your x's. So who is my smallest x? 11. And then 12. And then 13. And then 20. They happen to already be in order. Isn't that sweet? Okay, range are my y's. So let's see. Who is the smallest y we have? -2. Now it happens more than once, but I don't write it more than once. And then -1. And then 7. Okay, so now let's look at the ordered pairs. So 11 goes to the -2. So draw an arrow from the 11 to the -2. 12 goes to the -1. So 12 goes to the -1. 13 goes to the -2. So 13 goes to the -2. And 20 goes to the 7. So 20 goes to the 7. Okay, so looking at that definition again that I like to use with the mapping, each x can only have one y. So let's see. This x, it only went to one y. This x only went to one y. This x only went to one y. And this x only went to one y. So yes, that is a function. So I know you see the 11 going to the -2 and the 13 go to the -2, but it's okay if y's repeat. It's just not okay if x's repeat. And that's like your dollar menu at McDonald's. You know how like fries is $1, a Coke is $1. You can buy several things for $1. So it's okay to buy different items that cost $1, but it's not okay for you to buy an item and one person pay $1 and one person pay $2. So this is like, pretend that this was $1. It's like if somebody ordered the number 11 and it cost them $1, and somebody ordered the number 13 and it cost them $1. That's okay. It's okay to order different items like your French fries and your Coke, and you both pay the same amount. But what's not okay is for you to order the same meal and you have to pay different amounts. So that is not a function. Okay, and that's that lesson. I hope you enjoyed it. Smiley face.